Oh, g'day champions. Fancy seeing you here. We've got a Princeton Reverb silver face here. Let's see if it's abused like all the other silver faces that seem to come in. This one came in with reports of blatty distortion. Blatty distortion. It's a good term, isn't it? It's been recapped multiple times apparently, so that's a worry. He's heard about the wax conductivity issues on the board, so he said if that's an issue, remove the wax, if possible clean the board. The reverb driver valve, I had a quick look, is the wrong type, so that's a worry as well. But anyway, we'll get into this thing, have a look and see how badly it's been abused, because almost every silver face has, and come up with a game plan. Right, so we've got a bit of the old filiform corrosion, which is when a base metal corrodes under a coating or a plating, and you end up with that weird sort of little almost like insect trail, like you'd see on like wood borers or something, as it makes its way under the finish. As far as I know, nobody really does any reproduction silver face panels, which you know, if someone figured it out how to make them look genuine, they'd have a monopoly on their hands. So anybody out there that wants to do it, go for it. Let me know when you do it. It looks like they would have had some kind of abrasive disc and then run it through on a fence. Like you could probably do it on a drill press if you're real fancy. The input jacks there, we might be able to clean them up. I'll just take the nuts and washers off and give them a bit of a solvent bath and wire brush. The knobs, I'm not sure how much he wants this clean. I might contact him and just say, look, do you want me to clean them up, or do you like the grungy look? Personally, I'd probably like it a bit cleaner than that. Sort of like that reverb knob there. Obviously that doesn't get adjusted as much as the other ones do. Got quite a bit of corrosion on the hardware. So it's probably been exposed to quite a bit of moisture, which probably doesn't bode well for the conductivity of the eyelet board inside. Top straps are pretty rusty as well, and the screws are pretty reamed out, so again that doesn't bode well for any work that's taken place inside. If whoever worked on it last will ream out screws, then they're probably just as careless inside the amp. Now just a quick look at the back. We've got a fat Jimmy down there. Hopefully Jimmy gets some assistance with his weight loss program, but in the meantime we'll see what that sounds like. Now the first thing I noticed was this adapter coming out of the vibrato pedal jack there. Like, why is that a 1/4 inch jack? And why is there an adapter? So I'll investigate that, and if need be we'll put another Switchcraft RCA jack on the back like it should have been. Alright, so straight away we've got mismatched screws, mismatched cup washers. We've got 3 flat heads, 1 Phillips, and they're stripped out. Awesome. Okay, well they're stripped because they're way too small. So we'll have to replace them with the correct size screw and Phillips as well, so they all match. Have I ever told you how much I hate flathead screws? Well, I hate flathead screws. Alrighty, so starting from the rectifier end, oh, that came out really easily. We've got a Phillips 5AR4. It's got the seam in the glass. That came out really easy too. Tongue sole, made in the USA, cracked base, 6v6 GT-G. Looks like a pin's been glued back in place, but still appears to have the getter down there, so it's still got vacuum. We've got a Radiotron Australia 6v6 GT, so 2 different brands of valve there. In V4 we've got a 12AX7 arse. Always makes me giggle because I'm a 12-year-old boy. We've got a 12AX7 V3. V2 we've got a 12AX7. Should be a 12AT7. And V1 we've got a 12AX7. So all 12AX7s. Whereas it should be 12AX7 in V1, 12AT7 in V2, 12AX7, 12AX7 in 3 and 4. Having a 12AX7 in V2 would result in a pretty weak reverb, because it's running in a completely different region that was designed for a 12AT7. And we'll get rid of that adapter for now so we don't damage anything. Let's check fuse rating. got a 2 amp and it's intact. It's supposed to be a 1 amp, but that's for the multi voltages. They set the fuse, or usually the fuse is documented for the lowest voltage, so the highest current. When you go up to 240 volts, you could put a 500 milliamp in there and you'd probably be right. So let's hope that oversized fuse hasn't caused any troubles. You can see the reverb leads here, they're really corroded. So they should be replaced. I'd like to put some nice switchcrafts on there if they weren't bloody $18 each or whatever they are. Just check the resistance on those leads. Pretty dirty, trying to break through the crust. 160 ohm on the return. And 1 ohm on the send, so that's promising. I think that the tank and the cables are okay. But we'll inspect the other end down the tank as well and just make sure there's no corrosion or dirt or anything. Just having a look at the speaker terminals, they're not soldered very well, so we'll rework all of that. Just a big blob of solder there and just tack soldered, so it's not even passing through the eyelet. And the other end appears to be original fender. Just have a look under the cap. Yeah, it's all looking alright. It's always a little bit tricky undoing these where they're hiding behind the transformer. Not so bad on the Princeton, but some of the other models, it's really hard to get your hand down there, and because it's got a little caps nut on the other end. So this just appears to be a chipboard cabinet and baffle. It's one of those dadoed in baffles, which sucks a bit. If you want to get a nice replacement baffle on there, you'd have to flush cut it with a router or something, and then mount some cleats on the inside, which is doable. But it sucks a bit that they went to chipboard. Could have at least used ply, but nope, too expensive for Fender back in the day. And out she comes. We'll just give the speaker a quick test. I've got no reason to think that it wouldn't be performing fine, but you never want to get bitten in the ass by a reasonably large extra cost like a new speaker when you haven't allowed for it. So again, just gave it a sweep, give it some low frequency, and there's no appreciable buzzing or weirdness to it, so that's good. We'll set that cabinet aside, get it out of our hair, not that I got any. So just a quick look at the chassis. Looks to be all original transformers and sockets, but not an original filter cap. So that's made in Australia. That's a Ducon. You find that on quite a few Australian made amps and quite a few amplifiers that have been restored before I was born. So you can see there the date code, 51st week of 1972, so just before Christmas. She's going to be a quality cap. Building something the week before Christmas in Australia, it's probably not when you're going to get the best quality. we get a bit festive towards the end of the year, let's just leave it at that. But we've got 24, 24, 24, so this is a 3-section cap, so straight away we're 1 section short there. The original AA1164 Princeton had 4 sections at 20 microfarad, 450 volt each, so the voltage rating's fine. You know, the capacitance rating's got a fair bit of tolerance to it at the best of times. You're not going to hear the difference between 20 and 24 microfarad, but we're 1 section short, so we've got 1 less filter node. Now the original cap would have had tabs soldered to the chassis as well, but someone's drilled some holes and put a cap clamp on there. So that will help us out if we want to reuse a multi-section cap. There's a lot on the market that aren't really reliable. They've got a temperature rating of like 65 degrees, which is pretty pathetic. I prefer the JJ's ones. I've heard other guys having the occasional failure of them as well. But I've been okay with them so far. So I don't know, maybe keep using them until I get bitten. You can mount separate caps inside on tag strips and stuff, but if you want to keep it original looking, you kind of got no option but the JJ's one. It's got those annoying sockets that I hate, where the contact's like 5mm, 4mm down inside the hole, which is just It's good from a safety perspective, I guess, but it only grabs onto the very tip of the pin, so not very reliable and doesn't really hold on to the valve that well. And oddly, you've got one bear trap there, retainer, and none on these ones, so not sure if that one was added or if those ones were removed for some reason, or if it just came with one for some reason. Alright, so look in the guts. You've got a couple of replacement parts there. You can see straight away those yellow coupling caps there. Looks like someone's replaced the bypass caps at some stage, but they look pretty old. And then you've got this this shit show over here. Not only is the lead dress about as good as it looks, but you've got the original cap still in circuit, or two of the three sections it's still in circuit anyway. And you've got these two paralleled. You got this one down here, so you've still got what, 1, 2, 3. You've got 4 filter stages between the 1, 2, 3, 4, 5, 6 caps. So let's run through what they've done. Alright, so what you should have is your input from, or your output from your rectifier onto your plate node for the output valves. That goes off to the center tap of the output transformer, and that's it. The only other place it goes to is the next, the dropper for the next stage, which should be, well, originally was a 1K 1 watt. They've put a 1K 5 watt. No harm, no foul there. And then you've got your screen node. So that should take off to the screens. Yes, it does. Up that white wire there. Now that also has a little link wire down here, which is supposed to feed the reverb driver valve, the 12AT7 V2, but this red wire here goes off to V4A, supplying the plate of V4A. Now V4A is the vibrato, or tremolo, whatever you want to call it this week. So they're feeding the vibrato valve off the screen node. I think they've gotten the wires mixed up here, because that yellow wire, orange wire there, sorry to anyone that's colorblind, that pisses off to the reverb driver. So I think someone's reworked this area and they've got them back to front. But then you've got instead of an 18K resistor, you've got a 4.7K resistor. And then that goes off. This is it using the old can cap, or the replaced but still old can cap. There's nothing else connected to that node other than the reverb driver in the wrong node. And then it's got another dropper there using another section. This section's been disconnected, and then that goes off to the preamp node, right? So just completely arse backwards, and all of that's got to be ripped out and redone. This whole area is going to be removed. That resistor, all these caps, that chassis cap, this stupid thing, all of the grounds are going to get removed from the transformer mounting hardware. Your bias supply down there, instead of getting the right value resistor, they've series some up. Still seems solid, but I'm going to redo that whole lot. Replace the electrolytic down there. Everyone forgets that the white molded caps are still electrolytics. They need replacing as well if you're going to do a recap, especially that one because it's a bias supply. You've got stuff shorting out and other stuff. That's just another ground too, so no biggie there, but stuff real close to other terminals. Just everything's got to get looked at closely, because I don't trust any of the work after seeing some of that stuff in the power supply. So the previous tech has replaced the 2 bias feed resistors here. That white wire's going off to the intensity pot, which is the bias supply as well, and that feeds the grids of the 6V6s. Now I reckon sometimes with these amps you can sort of tell what the previous tech thought they were thinking. They probably had a bias drift problem, and they thought it was something to do with these resistors, so they just replaced them and had a wild guess there without really thinking about it. This here is the plate supply for the phase inverter, and there's a very small distance between this junction here, which is the bias supply, relatively high impedance power supply there for the bias, and the high voltage there for the plate supply for the PI. So when voltage leaks through this area here, which happens quite often, it drags the bias voltage upwards from its negative voltage towards 0, and that will make the output valves conduct a lot hotter than they should and overheat. And often people think it's coupling caps, so they change them, nothing changes. Then they change these, nothing changes. They don't realize it's actually leaking through the board itself. They might resolder stuff, think they've fixed it, but what they've actually done is in the process of just doing guesswork in this area and heating the board with their soldering iron, they've actually evaporated some of the moisture and stuff that's in the board that's actually helping it conduct. So for a little while after servicing, it'll come good, but then the problem will return later because the board will continue to absorb moisture and dirt and crud on the surface of that wax as it heats up and absorbs stuff in the wax surface and cools down, and it stays there and builds that layer up over time as it repeats that cycle. But more annoyingly, you can just see everywhere where there's been rework, they've melted the living shit out of the wires. They've actually burned it to charcoal in some areas. Like everywhere where there's been any work done, there's melted insulation all over the place. All that wire's got to be replaced. You got melts everywhere. Just like, look at where your barrel of your soldering iron is. It's really frustrating because essentially I've got to charge for this time, so the customer is being screwed still by the previous tech and their incompetence. So in summary, I think I'm going to quote for just removing all of this shit, all the caps coming out, replacing these two, just rewiring everything, replacing all the melted wires, which is probably the biggest labor intensive task, cleaning areas of the board, reworking this area, so if we can't get the leakage to a low enough point where it's satisfactory, then we'll fly this center junction up in the air and mount the wire up there so it's not a problem. There's other leakage points as well, like down here for example, so we might look at separating some of those by flying some components if we can't get the board to behave itself. So we'll replace the bypass caps because they look ancient as well. I'll just clean up all this area, just better lead dress, remove some excess wire wherever we can just to neaten things up. Check all the resistors for drift, all the carbon comps, particularly the plate loads and the droppers. We'll see how these valves perform, even though they're a mismatched set. Probably a good idea to just quote some replacements there. Everyone's got a hard on for old valves, but at the end of the day, they're just, once they're like this, they're not really reliable. We'll put the proper 12AT7 in for the reverb driver and fix up the nodes, make them as per the original circuit. I'll replace this jack with a RCA from Switchcraft, so it'll be like the original. Might put some backup diodes on the rectifier like I like doing these days, and maybe some flyback protection on the output in case the speaker ever gets unplugged. Just all the pretty standard stuff I do to make Road Warrior amps bloody super ultra mega reliable, mate. All the terminals will be removed from the transformer hardware, particularly the safety ground. That's no good. And these switches are known to fail, the voltage selector switches. This bit of phenolic backing here just warps over time and starts losing contact. It's only held in by those little tabs, so we might disconnect all of the unused primaries and just hardwire it to 240 volts because I don't think this is going overseas anytime soon. That's just one less thing to worry about then, one less contact, one less link in the chain to break. Alright, so it looks like some dickhead has used like some kind of grease, Vaseline or something on the valve socket. These other techs, man, they've really got to just give it up, eh? Just go and take up gardening or something, would yous? Stop making my life hell. So I'm gonna have to clean all that out with solvent. See if it doesn't look like it's corroded anything, but it smells like mineral oil. But it's clear, and it's sort of gel-like. But when you put any sort of grease on a electrical connection to try and use it as a dielectric, well, you know what it does? It collects all the dust that touches it because it's like a grease, right? And then, yeah, the dielectric grease may be dielectric, but the dust and shit that it collects moisture, and that's not a dielectric. So it's worked against you by using it. If you had nothing there at all you'd have to do is like clean it with a bit of solvent and blow it out, and you're done. Now I've got to clean all of this solvent off and scrub it out and make sure there's no trace of it left. I don't know where these people get these ideas from. They probably swear black and blue that that's the way to do things, and you know, they just mindlessly do it for their whole life. Super frustrating. So I'll see you on the next episode. We'll see if this is a 2 or 3 part one. I'll get most of the work done and we'll give it some sound samples, see if we can fine tune it any further. So I'll see you on that one, you bloody lot of legends.